give you Kumar Ramaswamy from igolgi, who will give us a wonderful presentation about advanced video encoding and distribution techniques.
Thank you. So igolgi, just by way of introduction, we are a 16-year-old company, actually 17-year-old, running on 17 right now. We serve broadcast cable and satellite markets. We process, mostly audio-video processing for live, file, and now increasingly just-in-time applications. The company was built on the premise that all this processing that's happening in audio and video is going to go into software, and so we are primarily a software company. And the name igolgi comes from our very first project that we did back in 2008 on the cell processor, which the IBM had for the PS3 game machine. It was a Linux-based engine, and it was an 8-core processor. Just for reference, Intel at that time was just doing dual cores. And so IBM was way ahead for the gaming market. But we saw that the world for video processing is going to do the same thing that was happening with audio back in the early 2000s. So we Jeff Cooper and I were working at RCA at that time. I was the CTO and Jeff was running video products. We decided to quit our day jobs and start igolgi. And the name comes from the root Golgi bodies, which are the DNA of the cell. This was the easiest name to register that we were able to register actually at that time. We were up to 3-word names and couldn't find a way to register it. And igolgi wasn't registered, and that's the root of the name. The DNA, the brains of the cell. And the cell went the way of the dodo, right? And Intel then started coming out with quad cores, and so we moved over to the Intel and AMD processors. So we are still, a lot of our software written back then, codecs and transport layer and encryption and all the stack that we wrote was all ported over to the Intel processor, Intel AMD engines. And increasingly over the last 5 or 6 years, we have moved them to GPUs, both Intel and NVIDIA GPUs. So we do a variety of encode, packaging, encryption, transport layer, playout, and more increasingly, a lot of this is being done on NVIDIA and Intel GPU clusters. Our lab is in Barrington, Illinois. I live in Pennington, New Jersey. We have a lab in Barcelona, Spain as well, and our headquarters is in Princeton. We have a reasonably broad footprint of satisfied customers over the last 16 years. For a while, we were rebranded by Larkan, and then when Larkan went out of business, we were rebranded by Anywave, and in the broadcast world. And in the cable, Vecima and CSI, there are several companies that resell our product. And in satellite, there is an Israeli company called Novelsat that rebrands our product as well. And so we have kept ourselves as a technical company and resell through other resellers. But over the last few years in the broadcast world, we have started to sell our own product with the igolgi brand name. That's the kind of the footprint of where we are countrywide. The reason I provide this background is to kind of talk, is kind of relevant to what I'm going to talk about. It kind of leads into where all this is going. This is our footprint in the broadcast world. We are in about hundreds of mostly low-power television stations, several Class A and several full power as well. We are also in about 15 ATSC3 locations. We provide encoding and the whole stack, actually, encoding gateway, broadcast gateway, and signaling gateway for the ATSC3 platform as well. So now this leads into my talk. So what are the future of broadcasting in our mind is about content curation and distribution. Of course, there is the whole concept of transmission, but transmission is well understood, and it's a fairly well isolated technology. Other than cellular, there is, broadcasters have their domain in transmission, and it's fairly well understood. However, what broadcasters really do is curate content and distribute content, and that's where it gets really murky with all the world of the internet. where there is so much happening out there that if broadcasters remain siloed in transmission, then there's a chance that they become irrelevant over time. So our contention, or at least my personal contention, is that broadcasters should view themselves as content curators and distributors. What does that mean? In the world of ATSC, the transition is, of course, happening from ATSC 1 to 3. But in the meantime, one of the challenges that we have seen over the last, I would say, 6 or 7 years is the transition to ATSC 3.0 is fairly painful because of a variety of economic and end client television support reasons. So we started to think about what is the better utilization of the ATSC 1.0 spectrum, and clearly there was a standard that was the 872 that was developed back in 2008 by ATSC. The FCC never formally approved it, but in fact, I was at an NTA meeting last week or 2 weeks ago, and the FCC representative there said, even though it's not been approved officially, we know that this is the right thing to do for broadcasters to kind of, other than the .1, which is the mandatory to be in MPEG 2, all the other services can be viewed as auxiliary services and transition to MPEG 4 with two very useful outcomes. One, it gives you better efficiency. You can do better, either you can do better quality, much better quality, right? Or you can do twice the number of channels. And even at twice the number of channels, H.264, given the quality of tools that they have, it is definitely better, the video quality looks better even at half the bit rate. So that kind of allows you to offer more programs and increase monetization. And we will talk a little bit about what shape that can take. And of course, in ATSC 3.0, it's HEVC video coding is the mandatory requirement for the standard, and in ATSC 3.0 one way. The other aspect of broadcasters, right, what broadcasters should be considering is how to become content creators and do play out. This has been mostly relegated to the realm of studios, and the traditional model says, hey, you need a large studio to create content and do play out. The internet providers today, the OTT providers, are proving that that's not necessarily needed, right? It can be done fairly creatively using a variety of tools that are available on the internet and reasonably inexpensive to do channel creation and to do play out. To do channel creation and play out is becoming extremely cost effective. And so as you start getting more potential for putting out more channels, the question is, if you have content, can you take that content and recreate channels, and how do you monetize them? That's also fairly straightforward. Doing ad insertion and being able to do ad markers and to do ad insertion either on the server side or the client side is turning out to be fairly cost effective and very easy to do with almost a simple Linux server. And so we'll talk a little bit about what that means and how to go about it. And then the other side of the story is content broadcasters can also, as long as they have the rights, they can think about creating, while they create OTA streams, they can simultaneously create OTT streams, the over-the-top streams for the same set of channels that they are playing to air can be played over the internet. And as long as you can host it, then you have your end user and subscriber, or the end client or the end viewer not only watches the same programming over the air, but they can also watch it over other devices, the most useful of those devices being the cell phone, especially with the younger generation. My kids, right, they almost never watch a big screen television. Most of their content gets watched on smaller devices, and over the top, right? So this is keeping them in that, watching the same, all this content and making it easily accessible seems to be relevant for broadcasters. And so the other aspect of this is the monetization aspect, and I'll talk a little bit about that, is this programmatic and scheduled ad insertion. How to do this extremely efficiently and completely programmatically, so that you can compete much more efficiently with streaming providers, the YouTube TVs and the and all your favorite fast channel providers today. That whole workflow, it turns out that is not all that complicated and can be done fairly efficiently by broadcasters. And so doing OT and OTT distribution doing OTT distribution using the internet seems to me is the way broadcasters need to be thinking about their evolution. So this actually, the concept of I-beam, we kind of tried to lay it all out in a common rubric, so to speak, is the idea of creating linear live workflow, of complete workflow for linear live. So at the bottom left is the ingest of the channel. And by the way, this can be coming over the internet. It can come on, most of the time, content gets in. Sorry. Content gets ingested over IP from various sources, be it SRT, ZigSee, HLS, or the traditional RTP, or it can be baseband as well, right? And inside the studio, a lot of the SDI workflows or the 2110 workflows can all live on the top left. But whenever compressed content gets ingested, the first aspect of a network operation center would be to take that content, terminate it, and then convert it to a multicast so that it can be ingested by the rest of the infrastructure. The one other aspect that I want to start, emphasizing is the notion of shared infrastructure for broadcasters to consider, which is a data center NOC, right? This is a way for, it's both cost effective, much more reliable, and it allows you to do things in the broadcast infrastructure that you could not do as a single station. And then on the top left, the live production workflows. By the way, all of these can be done with standard hot servers running software and very reliably, right? And I will show in a second what we have done with a certain broadcaster who's actually got 100 stations or 80 plus stations on air doing exactly this architecture. But on the top left, you see playout. Playout is basically either live or file feeds, can be SDI or it can be IP or it can be file feeds. Of course, you pull files, and then playout servers are playing to a simple rundown schedule can be created. So you create live channels, you create stream channels that are then fed to these bank of encoders, and which are capable of doing ad insertion, EAS, PSIP, all of this gets integrated into these encoders, which is what our encoders do today. Our encoders are capable of doing all of these functions, including live ad insertion. Recently we have introduced a functionality in our encoder that will allow you to do live ad insertion, which means you talk to some ad provider, and then you have an ad inventory. Based on queue markers, you can insert ads on the fly. So this kind of integrated functionality allows even a small broadcaster to create multiple channels, do ad insertion for monetization, and put these channels. And by the way, these channels are sitting at a data center. They get SRT'd over to a remote transmitter site. And there, basically, you have some kind of an SRT reception, and which then goes on air into the modulator. The other interesting aspect of this is you can return feed the off-air channel. In fact, we have an SRT receiver box that has got an RF card built in that can also receive the channel that you just put on air, and it can be SRT'd back to the monitoring for centralized monitoring at a centralized site. Architecturally, what this allows you to do, allows you to do several things. One, you can get redundancy, N over N plus 1 redundancy if it's a shared infrastructure for multiple stations. So your redundancy is actually built in with a very reasonably modest cost. You can do redundant encoding. Redundancy is built in. The other aspect of this whole thing is live monitoring. These kinds of monitoring tools, we have actually introduced a product called Visionaire that's primarily for IP infrastructures, although it can take in ASI and SDI as well. But the cost effectiveness of this is it's a GPU-based platform. And the cost effectiveness of this is really borne out when you have all IP infrastructure. And the idea is that it can monitor all incoming feeds, all generated feeds, all outgoing feeds, and all off-air feeds that come back over SRT back into the monitor. And this kind of a monitoring capability does two levels of monitoring. One is QoS, namely transport stream and all the compliance requirements and all of that stuff in IP streams. And it also does QoE monitoring, namely the quality of the audio and the video. So if there is blockiness or if there is degradation in video quality or audio quality, this kind of a monitoring system is capable of monitoring, alarming, and sending out automatic information to operators so that they can kind of handle the situation very quickly. And just to the point I'm making is that all of these things get done on Linux platforms. All of these boxes that I show here are Linux COTS servers running software. This entire infrastructure is a big set of Linux CPU, GPU platforms running software. There is almost no it's all commercial off-the-shelf software. There is no specialized hardware running any of this infrastructure. And I think this is the way of the future, because this is what OTT broadcasters, YouTube TV, or any of these guys are doing today. That's how they are fairly cost effective in these infrastructures. And so anything that a traditional broadcaster needs to do is to adopt this kind of an architecture to be cost effective, to have the reliability and the ability to do monitoring fairly robustly in this kind of an infrastructure in a very cost effective manner. That same infrastructure can also deliver, taking that same infrastructure, you extend it to deliver over-the-top streams by over-the-top transcoders. Again, all of these running on COTS servers. You can build in streaming servers and go over the internet. So your origin serving HLS- streams of all the content that you are capable of putting linear on air, you can also OTT deliver them at the same time. And we have done this with a few broadcasters. One notable one is a broadcaster in Kansas City who takes several of their off-air channels and then delivers them over the top simultaneously. And they have rights to do other channels that are not even going on air. They pull them in, and so they create a bouquet. So it allows a broadcaster to start offering bouquets of channels of shared, whatever they have rights for to go on air, that they have rights to distribute over the top. You can start doing that. And it can be geo-fenced so that it's only within the DMA that it's intended to be in. And so as you start negotiating rights for broadcast for content, you negotiate the rights to do over the top simultaneously. That gives you a more relevance for delivering content to endpoints such as cell phones. And so ATSC3 is one way to get to a cell phone, or 5G broadcast is one way to get to a cell phone. Another way to get to a cell phone endpoint is to go do it with an OTT streaming infrastructure, which can be actually fairly cost effectively housed on premises of a broadcaster. So this is our kind of pitch to the direction of where broadcasters need to be thinking about adding capability within their infrastructure. And usually there is plenty of fiber capacity and plenty of bandwidth to kind of deliver these kinds of services over the top. So that's the over the top and over the air simultaneous kind of creation of broadcast services. What we have done as an example, we have kind of created for a low power television provider called Bridge Media. They are based in Farmington Hills, Detroit. And at their broadcast center, it's an NOC-based broadcast center. They have 85 plus ATSC low power and mix of low power and class A and full power television stations across the country. So we built their stack to do all their encoding, and now they have started to do ad insertion, and they are the one station that went full MPEG-4. So their primary channel is MPEG-2, but they run SD 14 to 16 or even 17 up to 17 channels of SD broadcast based on H.264. And they also had started an OTT service with their initial channels, which we built out for them. This entire infrastructure actually was put in place in less than 18 months. That included building out some of the stations that they had to build out. The network NOC itself, housing all the encoders. By the way, EAS, everything gets done at the center, at the site. PCEP, EAS, all that injection, everything gets done at that broadcast facility in Detroit. And all you're doing is sending SRT streams over public internet infrastructures to all these stations. And these stations have SRT receivers, and then they receive them, and then they put them on air in all these stations. So this architecture actually I would say about 15 or 20 years ago, the concept of centralized NOC-based infrastructures, I first saw at the Syracuse PBS stations in Syracuse, New York. They had already started thinking about the PBS stations banded together, and they put this combined infrastructure together back in the day. But this is a more modern version of that. This is kind of using public internet infrastructure for distribution. So all of the station encoding gear and the redundancy and the monitoring and the EAS and the PCIP, all that gets done in Detroit. And you just send a stream out over public internet to all these endpoints using SRT. So secure, reliable transport, for people who are not aware, is a fairly robust technology that allows you to send streams over the public internet. And it has got a mixture of ARQ and FEC to make sure that the streams reach reliably. And we have some benchmarks on, for example, the last 18 months of operation. It's near 4 nines or near 5 nines, actually, availability of the SRT system itself using the public internet. So you have to slightly over provision. So for example, if you need to send a 20 megabit stream, you need to have over 25 or 28 megabits on either end, so that you if there is a repeat request, you can take care of that. And that's the overhead that we have typically seen. So having about 30 megabits is pretty safe. And the 4 nines that I'm talking about are achieved mostly from all these sites having that kind of bandwidth for reception. So the next discussion that I like to talk about is how do broadcasters have better monetization of the spectrum that they have, right? In the world of ATSC1, doing more channels, doing more programming. And this is what Bridge has decided to go down this path. They are doing mostly SDE, but if they get more HD clients, they will kick off some of the SD clients, I bet. The whole idea being that you can create almost like a mini cable system if you can create 14 or 15 channels. And if there are several broadcasters doing that, then you free to air, which is monetized with the cable, with the ad monetization, using ads, is very, very effective and can rejuvenate, I would say, the entire broadcast infrastructure in the country, even with ATSC 1.0. Of course, as ATSC 3.0 matures and more endpoints become available and more broadcasters transition, this concept of monetizing, having a very large channel count as an alternative to either satellite or cable or over-the-top providers, but free to air, would be, I think, a very attractive alternative wherever people can put up antennas. And I just heard earlier today that in DC, he was receiving 71 channels, which is a pretty decent channel count already. But if all of them convert to MPEG-4, you'll start to see a much bigger channel count of interesting programming, niche programming, ethnic programming, and also special interest programming, right? And so all of that can start to show up, which is what is happening on YouTube or any of the other broadcast, Roku, or any of these programmers that you see today. I call them programmers because they are actually aggregating programming. And so broadcasters need to think of themselves as aggregating programming as well. And they can do it far more easily and far better than what I see on what is being done on the internet today. Higher availability, obviously getting a standardized NOC-based data center would give you a lot of value in terms of, especially a shared resource like that, gives you much more cost-effective end-to-end monitoring, and it can be scaled to the size of the network. So availability also, I think, improves with automation. It's an automated way of producing more channels cost-effectively and with higher availability. And of course, the monetization of these channels can be done with diginets and other ingestion of other content, like I was showing at the bottom left. Ingesting other sources of content can all be done over SRT, ZigSee, or your favorite HLS ingest sources, and then they can be reprocessed and re-encoded into the StatMux encoder and put on air. So there is more niche programming that can get generated, including high school sports, education, local education programming. All of that can get into this kind of a workflow, and it is extremely automated and highly effective, cost-effective to run these kinds of services. And then monetization of this using server-side ad insertion should be done in a completely programmatic manner, meaning the whole ad inventory you can go to a double click and pull down their local ad inventory, or there is a number of players now in the industry like WorldLink and a number of people, Orca and all these guys who are offering geographically local program genre-based program, demographic-based program ad insertion, and it's all programmatic, and it's done with APIs, and you can ingest these ads and insert them wherever the avails are. Or if you've created your own programs, then you know where the avails are, and you can insert these programmatically. And this can be done inside the encoder, and ideally it should be done inside the encoder. And similarly for OTT, you can kind of do the ad insertion. Again, you're creating program bouquets with ad markers placed, and then giving it to the brokers who then do the ad insertion. And the end game right now is typically Samsung or LG or your Roku or Pluto are the larger ad who take programmatic, or who take such programs, and then they end up inserting ads, and that's how the monetization happens, and the revenue flows back to the people who are providing the OTT channels. Typically, it's a rev share. If for example, a broadcaster decides that they want to keep this still free to air, they just have a way to distribute it to end providers. If they are publicly supported, then that can be free distribution as well, but over the top of the programming. So the whole idea is that you can create linear or OTT channels for distribution using a platform of this type fairly easily and without a lot of cost, adding a lot of cost to the gear. So that, because this is actually totally enabled by the fact that GPUs and commercial off-the-shelf servers are extremely cost-effective in creating this kind of workflows. And so the idea is that our belief is that broadcasters need to think about transitioning over to become both content curators. And that's why I mean by curating content, you're actually taking some either licensed content from somebody else, or distributing somebody else's content for a fee, such as a diginet, or you are originating content or you're taking content from a content provider and on their behalf creating linear channels or what have you on a very programmatic basis with a fairly low touch points in the system. And I think that's the whole name of the game, is to make them very programmatic and extremely efficient from a human touch point perspective. And so the transition to ATSC3, I mean, in this world, will actually require you to update the StatMux encoder with an ATSC3 encoder signaling components. We have actually developed this entire chain as well. And our view is that transition from ATSC 1.0 to 3.0 for customers who use the centralized NOC architecture would be extremely painless and fairly seamless. All you do is replace your encoder and the signaling gateway with ATSC3 components, and the rest of the workflow will remain identical. EAS and PSIP will need to rework in, but we have done that actually on behalf of several customers, and it's fairly quick as well. And so the idea is that if you transitioned over to a centralized NOC-based workflow, like I showed in this diagram, the idea is that shared services, originating content, redistributing content, having a way to monitor all your workflows, monitor what's going on air, all of this gets done at a NOC. And it is the role of the broadcaster to make sure that these services are delivered in a very seamless way with monetization using programmatic ad insertion as it needs, or other means of monetizing the content. I think that's pretty much what I had to say. I would like to say that, in conclusion, I would like to say that the role of the broadcaster actually needs to evolve to embrace both ATA and OTT workflows in a very systematic way. Broadcasters need to be thinking about not just the transmission side of the business, but about the broadcasting side of the business. And that means that it is partially the studio, but it is also partially this data center infrastructure that I'm talking about. And linear program channel creation and ad insertion should be totally automated. It's a completely automated, and that will allow small broadcasts to originate and monetize content. And data center NOC operations are all IP workflows. They are not, I think, and systematically, people need to do away with SDI and ASI and all the workflows that exist today to go towards all IP. And then the other interesting aspect of all of this is, and this is particularly relevant for people who manage translators, the role of the transmitter or the translator become blurred in the service. So the translator can almost do what a standard transmitter does, and because it's getting centrally distributed from the NOC. So you can imagine translators having, in fact, niche programming, the translators can also start becoming local transmitters or local generators of content. And of course, this has implications with the FCC, and one has to understand what those implications are. These are conversations that can be had, except what it does is it kind of expands the role of the broadcaster to serve content to endpoints, whether it is coming over the air or whether it's coming over OTT, over the top, over IP. And the transition to ATSC 3.0 for broadcasters who are in the 1.0 world, transitioning to MPEG-4, the transitioning to 3.0 should be done when the time is right. When, for example, there are enough endpoints or end receivers that can justify the transition to ATSC 3.0. So it doesn't have that. There is this whole discussion that I keep hearing about broadcasters need to transition in 2028 or 2030. That actually becomes moot if, for example, broadcasters play the role of content curators and distributors. And over time, the transition to 3.0 can be done in a very incremental manner. And it doesn't have to be forced upon consumers who may not be in the right position to receive the 3.0 content or 5G content for that matter. So that's pretty much what I had to say. And, I'll be happy to take questions or listen to comments.
Kumar, David Gates here. Great presentation. A couple of questions, and I'm not being a smart tail with the first one. I'm going to be in Kansas City this weekend and then working through the week. And I often tune in various stations and take a look at how the data is distributed and have various pieces of equipment to do that. Is it fair to ask who you might be doing in Kansas City? And yeah, I would love to tune them in and see the outcome.
So in Kansas City right now, Brian Short, who runs a number of local stations, but I'll send you the call signs for what he does. There is a service that he also runs called igocast, IGOCAST. You can actually, when you're in Kansas City, if you go on your phone and look at igocast.com, you can do it from anywhere in the country, but you may not be able to see many channels because he has geo-isolated some of those channels to the Kansas City DMA. So you'll see whatever he puts on air and what he has rights for to do over the top. He has been doing this for, I think this is the 6th year where he's been doing this. What we did about 6 years ago was create this, but we have never figured out how to get broadcasters to kind of monetize it. And until recently, when we have started to introduce ad insertion. So we did that just as a trial service, and it has been running for the last 6 years. So essentially, he takes his broadcast bouquet and we built a stack to go over the top, which he has been using. And that's what, David, you'll see in Kansas City. You can go to igocast.com and you'll be able to receive a number of channels over the top. His over-the-air channels today are still in MPEG-2. He has been trialing MPEG-4, and he plans to transition to MPEG-4 on all his channels in the coming months. And by the way, he also centrally hosts a number of stations, including Cincinnati and Pittsburgh and all that from out of his Kansas City NOC. Those stations are also planned to be transitioned later this year to MPEG-4.
Excellent. I've got 2 more questions, but let me give somebody else a turn.
No, please go ahead.
Do we reach at some point a compression convergence where we've smashed everything as much as we can? Because we've watched over the years the quality of the programming and the way the data is manipulated is really given tremendous advantage. Do you see a point coming where we're using the data as a stream as effectively as we can, and we just can't do anymore?
Actually, today there are a lot of inefficiencies. In fact, recently we have been watching when we started to run 14, 15 SD programs in Bridge News. What we noticed, and the quality is pretty good, by the way. You can tune into one of their stations and you can look at the quality. It's definitely better than the MPEG-2 programs that we see on air. What we noticed was audio was packing audio more and more efficiently starts to become important. Because, each video, even though the video program, we are still encoding audio at 128 kilobits per second with the transport overhead, it is starting to eat into a lot of the 19.38. So we are trying to figure out ways to package audio, to put multiple packets in a frame and things like that. We are trying to package audio more efficiently than was done. Video compression, H.264, I think we have kind of, when we transitioned from CPU to GPU encoding, our efficiency went up a lot. And so wherever people are using our GPU platforms, the quality trade-off with efficiency is like reaching fairly high. We are doing full searches on a lot of and compression and things like that. We are rapidly approaching, fairly optimal use of the tools of 264. MPEG-2, there are a lot of limitations. And by the way, the GPUs do not support MPEG-2 encoding, only the H.264 encoding. And so we are still doing our MPEG-2 encoding using CPUs and not GPUs. And so when we use NVIDIA GPUs, we are able to squeeze a lot more and get much better quality in MPEG-4. And that's actually borne out when we look at it's much better than 2x the bitrate. It's more like 2.2 or 2.4 for comparable quality using the GPU platforms. So have we reached a terminal point? I think there is still some ways to go when you improve the efficiency of audio and you improve the efficiency. There is still a little bit of headroom on the video side. But then at that point, we would have reached the terminal with what we can do with 264. Then I think with one of the discussions we had at NTA this year was somebody asked the question, hey, can I put HEVC on ATSC 1.0? The FCC chairman's opinion or the representative's opinion was as long as it's an auxiliary service, sure. Because even 264 is not approved by the FCC. So he said HEVC, sure, you can do that as long as it's an auxiliary service. Your main service is still in MPEG-2. So that will give you another 2x improvement in compression. And we have kind of fairly good evidence because we have developed HEVC codecs. So we have seen 2x improvement. So coming back to our original point, with 264, you get 2x compared to MPEG-2, and then with HEVC, you'll get 2x compared to H.264. So you can imagine putting like 30 programs, SD programs on air, or 8 or 10 HD programs on air on a single carrier.
Gotcha.
With very high quality, right?
Last question, and I'll get out of the way. And I'm going to ask by analogy. You know, I'm friends with Bob, Frank, and Jeff of the three audio manufacturers, and there are distinctions that they will discuss that give them what they perceive as their advantages without trying to trip you into something that is unfair. Is there anything that you would tell us that maybe you do differently that gives you a competitive advantage, or a reason that, you know, you guys should go to the head of the class versus some of the other companies that make processors that bundle our audio or our video?
So I have a very simple answer to that. From day one, as a company, we decided that everything should be done in software, and not just software, but very modular software. So what we pride ourselves in doing is the ability to kind of build components and build workflows very efficiently. So everything is Dockerized, everything is in our software components are, you know, modular, fairly well tested. It gives us a lot of flexibility. It's like Lego building blocks we build, and then we build products built on those Lego building blocks. And so what it gives you is the flexibility. And that's why when we had to do ad insertion, or when we have to do EAS or station ID, or any of all of these components, or COM, all of these components are software components that we build from day one. And philosophically, we believe that this should be extremely modular and extremely replaceable, or Lego buildable, you know, Lego block buildable. And with that philosophy, we think the platforms that we develop and deploy have the potential to get upgraded, to add additional functionality in a very, very cost-effective way and fairly efficiently. And so that's, I think, where we have differentiated ourselves from a lot of the traditional vendors of video processing equipment. Of course, we do provide at the edges, we do provide ASI, SDI, all these interfaces through PCIe cards, but more and more, we are seeing those things start to fade away, and it'll be all IP. And so you can just buy servers and commercial off-the-shelf servers, commercial off-the-shelf GPUs, and run our software and be able to run your services. This can be virtualized, eventually go into the cloud. You know, there are so many options.
So if I can jump in and ask a strange question. So, you know, we've done TV repack a couple of times where we've, you know, done the digital transition, and then we've repacked in order to get rid of the spaces between channels. With advances in compression to H.264, H.265, HEVC, etc., at some point you get to a situation where a broadcaster has a certain number of channels, and they're probably not going to add any more. And you could pick an arbitrary number, 10 channels, whatever. Do you foresee a potential for a repack in order to reduce the width of a channel down from 6 megahertz, since you can fit the equivalent video quality and same number of channels into a smaller amount of bandwidth?
Great question.
Yeah, so I think I tend to think the other way. Actually, there are two reasons why the 6 megahertz redoing the 6 megahertz infrastructure is a bigger lift for the FCC than you know, and the chances of doing it incrementally are fairly low, right? So the 6 megahertz and given the legacy of the 6 megahertz availability of the 6 megahertz receivers is going to tail that out for a very long period of time. But the way I look at it is, if I have 6 megahertz of available spectrum, and I'm either doing ATSC 1.0, 19.38, or I do ATSC 3, which is a wide variety of bit rates, you know, all the way going up to 40 megabits or 50 megabits. The question is, when you say a broadcaster will limit themselves to 10 programs, I will challenge that assumption in the sense that why should they limit themselves to 10 programs? Why is it that they should not view themselves as a mini cable provider or a cable head-end provider and provide a variety of programming? What prevents them from providing 50 programs, 100 programs, right? If the efficiency allows them to do 20 programs or 25 programs, why won't they provide those programs? if it is cost effective to do so and there is a way to monetize it. So the spectrum becomes the most valuable asset for a broadcaster, and they should be able to monetize it in all the ways that they can. Either they can do 4 UHD programs, ultra high definition, or they can do 10 HDs, or they can do 50 SDs, or if the efficiency allows them, they can do more. And the question is, can they get the content to monetize it? That's it.
They don't all have to be visual programs either. I mean, there's space being taken right now in ATSC 3.0 that may replace GPS because it's very difficult to interfere with it because it's terrestrial and relatively high powered compared to satellite. So, it could be that these extra spaces will turn out to be 500 audio channels or some sort of data delivery for something else. It's going to be interesting to see what people just start to do with this stuff because it's there.
That is right. That's the way I think about it. Whether it's all video programming or whether it is data services, and like you said, other auxiliary services like emergency broadcast or even BPS, which is what I think you're referring to, the broadcast. Instead of GPS, they're using the BPS. Both ATSC 3.0 and the 5G, 3GPP world have come up with ways to do terrestrial positioning systems, broadcast positioning systems. There are a couple of different ways of doing it, and you're absolutely right. So that's it can provide. It's a critical infrastructure service that is probably just as important as entertainment video, or more important than entertainment video in many cases. So you're absolutely right. I mean, there is other way to deliver this data. It's IP encapsulated and in the ATSC 3.0 world. But as we transition to that, which is, I've heard this for the last 6 or 7 years. Every time I go to an AB, people say, hey, ATSC 3 is going to happen this year. The truth of the matter is that unless there is a critical mass of, it's like immunization, unless there is a critical mass of endpoints or television sets that can receive ATSC 3.0 or 5G for that matter, I think we will be stuck with having current technology still being relevant. And all I'm proposing is let's make that more efficient and more cost effective by centralizing the services and monetizing it in a very using programmatic tools that the internet uses today. Internet video distribution uses all these tools, and it's proven to be fairly economically good to do so. So why not borrow all those tools, bring them into the broadcast world, and just play the same game?
All right. Thank you very much for that answer. I'm looking at it from the standpoint of we kind of have in this country abandoned the idea of 8K television. We've kind of gotten to the point where 4K television isn't something that has taken off and 3D television isn't really something that has taken off. I'm not 100% certain that ATSC 3.0 is going to take off unless there's a mandate from the government in order for us to do it. And I would speculate that if there is a mandate, that mandate is going to combine a couple of different aspects, including the possibility of doing the broadcast positioning system in order to harden the positioning system in the United States. And at that time, if the government is mandating it, I think that it is probably something that they would consider doing in terms of reducing the channel width in order to free up additional spectrum, be able to auction off that spectrum, et cetera. So I don't think it's quite as far-fetched as it might be. From a station perspective, I understand that from a technologically, all it is software and licenses, and I could have 20 channels. Yes, absolutely. But from a financial aspect, do I have an automation system and the resources to program 20 channels? Or is the cost ongoing in order to do all of that programming and maintain those licenses and maintain tech support contracts, et cetera, worth it to me? Am I going to recoup that investment for 20 full channels?
The point is that point well taken. And this is what I'm trying to kind of provoke the thought that this can be done with automation, and it is not as daunting as it looked about even 10 years ago, right? Where you needed a studio, you needed to run a 24-channel system. You needed quite a bit of manual intervention, and managing the assets and things like that. Automation, one can imagine automating this in a fairly with a very, very few resources. For example, the 16-channel service that we run out of Detroit, there is one engineer who's supporting the whole service, actually. One engineer in the field and one engineer at the studio, at the head end. So how do they manage it? Because a lot of this is set up and left alone. Everything is programmatic. The monitoring is programmatic, the ad insertion is programmatic, the channel creation is programmatic, and the ingest distribution is all programmatic. So once you set it up, it just runs, and all you're dealing with is issues at that point. And so, to your point, can you do a 24-channel service? I think you can if you have with a very small, really small number of people. And the cost effectiveness of this per channel, if you look at it, it's a fraction of the cost of what a normal broadcaster thinks of spending, to stand up a channel. It's a fraction.
I'm going to ask a follow-up question about the cost. When you say it's a fraction, 9/10 is a fraction.
No, it's a significantly small fraction. So I can give you some numbers. I will have to sit down and characterize it in terms of cost per channel put on air, and imagine it's the way to think about it is the way I kind of think about all of these services is the amount of hardware I buy, commercial hardware off the shelf that I need to buy to run the service. The software is roughly 2 to 3x of that, and that's my total capital cost.
Okay.
Of any function in the system, pretty much.
All right.
Encoding, be it encryption, be it transport, be it play out, anything. So that is the most generic way to think about it. So if I'm buying $500,000 worth of servers, then I need to buy about $1.5 million worth of software, and that's what it will take to run a station of this type. Any other questions or comments?
I have another one, but I don't want to jump in unless nobody else does. So
go for it.
So one of the business models I'm wondering if you've considered is in building or in organization video distribution. So for example, we keep referring to Roku and smart TVs. It seems to me like there is a business model to be made for doing the equivalent of an in-house cable system, but putting it on commercial off-the-shelf devices like Roku's, either in a broadcaster's building or in a hotel or in an apartment building, or et cetera. And I don't know if that's something that you guys have considered doing, but since you're talking about using similar workflows for doing an over-the-air channel and over-the-top channel and a fast channel, it seems like this might be a natural evolution of those ideas.
Yes. In fact, about 4 or 5 years ago, we actually offered a small for the LodgeNet. LodgeNet was the company that does hotel distribution of content into hotels, which is a good example. And there is another example which was in Pennsylvania. The medical hospitals were trying to distribute content into the hospital rooms. So we were trying to offer a similar kind of a rebroadcast system for them that will pull off air, that will pull off cable or wherever the OTT content comes in, aggregate it, and then create a small mini local cable system. The problem with all of this was, as a company, we did not find a way to sell all this to. We developed the technology and we were able to prove the concept. But as a company, we are way too small and we haven't had the wherewithal to go off and be able to scale it and offer it as a service. I'm trying to currently work with some nonprofits that are rethinking how broadcast can get redistributed so that you can improve the viewership. so to speak, of broadcast content. One of the challenges we have is that the younger generation is pretty much stopped watching anything off an antenna, right? But if that same content, it's not because the content is not interesting, it is because they just watch it on a phone, which doesn't have an antenna. So the key is, how do you get that same content to them? And then, you back end them. And if they want to watch it on a large screen, they can either, they want to watch it in good quality, or if there is some niche programming that 8K programming they can't get on their cell phone, they watch it on a television set. But the idea that the user guide that allows them to just select a program is on their phone, and they're not sitting in front of a television. So how do you make all broadcast content automatically available over the top is something that, that's one of the things I've been working with some nonprofits to figure that out. It's not repeating Aero or Low Country or whatever the company was that did that just rebroadcasted channels, but this is a slightly different model that doesn't monetize the content necessarily when it is over the top. But I have a feeling that may be a way to keep the broadcaster content relevant and also viewable, improve viewership among younger audiences.
Thank you very much.